It provides the most natural view of infrastructure. It provides the most natural view of different complex data methods. And we believe that a few years from now, nobody is going to use flat maps when they're trying to figure out what to do and where to go next.
Hello and welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the geospatial community. Today I'm talking to Alec, and he and his company vGIS are leading the way in terms of augmented reality and geospatial. I hope you enjoy the interview. Hello Alec and welcome. Thank you so much for coming along and taking the time to talk to me today. Maybe before we jump into the interview, if you could just introduce yourself and tell us who you are.
Happy to be here. My name is Alec Pestov, and I'm the founder of vGIS, the visualization platform for GIS spatially referenced data.
That sounds interesting. And not that you've said too much about it yet, but I've seen a couple of videos, and I think that's why I reached out to you and asked you to come along and be on the show today, was because these videos that I saw on YouTube were incredibly interesting, because it looked like a bunch of people were doing geospatial work with virtual reality helmets on. Is that what was going on?
Almost, except it wasn't virtual reality helmet, but it was mixed reality headsets. And we will dive into the details of what's the difference between virtual reality and mixed reality in a second. But you're absolutely right. We developed technology that allows you to project GIS data as 3D visuals while working on site and using traditional tools, phones, tablets, mixed reality headsets.
Is this an application or is this a platform?
vGIS is actually both. It's an application and a platform. About 97% of processing happens in Microsoft Azure Cloud. What system does on the backend is it goes into various sources, Bing, Esri, Google, OpenStreetMaps, client GIS information, and then it puts it together into the visuals that address a specific problem. There is another component to it, which is the client-side application, which runs on traditional phones and tablets and mixed reality devices. So working together, they take GIS data and display it in full 3D on site.
Okay, in full 3D in these glasses, these mixed reality or augmented reality glasses.
Yes, the system, yes. So the system takes traditional GIS data, which in most cases come to us as flat. So it's flattened data, traditional lines, points, polygons. What our system does on the back end is, based on the strict set of rules, it converts that flat data, vector data, into three-dimensional visuals that are displayed through the app using traditional tools, yes.
Okay, and does this mean that people using the system can literally walk around the streets and see data?
That's exactly the idea. We believe that augmented reality and mixed reality is the future of field services. It provides the most natural view of infrastructure. It provides the most natural view of different complex data methods. And we believe that a few years from now, nobody is going to use flat maps when they're trying to figure out what to do and where to go next. Instead, they will use augmented reality visuals while on site, which will provide them a combination of visual feedback as well as the instructions and supplementary information they may need to do their job effectively.
Okay, so I'm thinking that don't you need more equipment than just these headsets? Do you need some sort of positioning system? Does the system, or does this all happen in the headset?
That's actually a great question because typically augmented reality in itself is not a new concept. It has been around since late 90s. Companies were thinking about ways of creating something that will display visuals in the field. The major drawback was on the visualization side. Simple tools such as phones and tablets did not exist 20 years ago. And another component to that was positioning. You have to have the accurate position in the field in order for you to see infrastructure projected relative to your position. To address that issue, we have two positioning methods within the system. One is the external positioning devices, traditional GNSS and RTK tools, such as Leica, Trimble, EOS, and also we have vGIS patent pending calibration method that relies on orthoimagery and object recognition in the physical world to identify users' position with high accuracy in the field.
Okay, so we've got this platform and an application, and just I'll try and summarize just for a second here for our listeners. So it sounds like that you've built a whole bunch of infrastructure on the cloud that can take different geospatial data sources and process them and send them out to your field kit, I guess you could call it, which consists of these headsets and a positioning system. Are those the now that's a lot, don't get me wrong, but are those the only pieces of equipment that we need, of infrastructure that we need to use the system?
As the end user, you actually don't need much. The way we design the system is with the traditional field service worker in mind. Typically, a field services worker will have a laptop, a tablet, and a phone. So giving them additional tools may not necessarily add much value. What we did at the beginning is we took the same approach Apple took when they designed the original iPhone. They took all the complexity and hid it under the hood so that the person with any level of technical knowledge can just start using it. We followed the same idea with our system. We wanted to eliminate additional hardware so that the person doesn't need to buy or carry that hardware. We also wanted to eliminate any complexity or complex workflows from the system so that anybody with any level of technical knowledge can just pick it up and start using it in the field. Now, to answer your question, aside from your phone or a tablet, you don't really need anything else to begin using it in the field. On the back end, though, you as the organization have to have access to existing GIS or CAD data in order for you to feed it into the system. The system is not necessarily a scanning device. It doesn't have capabilities of seeing through the ground. It's not the ground penetrating radar of any sorts, but it's fed by the existing GIS records that you may have in your asset database already. So the prerequisite for an organization to deploy the system is either to have that GIS database or have access to the GIS database for their clients or partners.
Okay, and just to be clear, you talked about other forms of data. Could we can we use CAD data as well in this system, or can we use maybe BIM data, things like that?
You actually packed two questions in one, and I will answer each of them individually. We do have capabilities for displaying CAD data. In fact, right now we're finalizing our interface with Bentley Systems. We, as far as we know, will be the first company or one of the first companies in the world to integrate our system with Bentley's iModel Hub. And that will let us take traditional Bentley formats and process it in a similar way as we do GIS data. So once you have all the drawings, once you create all the drawings for a construction site, we will be able to display it in real time on site, merged with GIS data. Building on that, we will also expand that capability to visualize other types of CAD data. Our plan is to expand the system to cover scene services and building services from Esri. That will address many of the integrations Esri has with Autodesk. And also we want to provide support for additional native formats such as Revit and Navisworks. It's all coming online hopefully this year. Bentley interface is finalized already. Esri interface is 75% built. So over the summer, we will release more extended support for Esri, and native formats we expect to develop in fall. The second part of your question was regarding BIM data. Technically, the system is capable of visualizing BIM data, but we found that visualizing BIM data effectively with augmented reality or mixed reality tools is a fairly difficult task. There are a number of companies that attempted to do it, and there are many companies that failed. One of the reasons for the difficulty of working with BIM data is that positioning inside buildings is very difficult to accomplish with high precision. You have to either provide markers or use some other methods for locating where you are in space. And in itself, it's not a very efficient process because if you have a multi-story building, you effectively have to go through every floor and mark every location on that floor. So that's one challenge. And the second challenge is the tolerances. When we work with utilities infrastructure in the field, and it doesn't matter if it's driven by GIS or CAD data, the tolerances are fairly substantial. You can be a few inches off of the center line, and in most cases, you should be fine. There are other tools to validate really high precision environments. When you're talking about BIM data, which is typically indoors, then the tolerances can be as little as half a centimeter or 1/16 of an inch. And in that case, the current state of hardware is not capable of providing that quality of visuals or tracking, and therefore it's risky in many cases to deploy BIM information for inside the buildings.
Well, thank you so much for clarifying that. I'd actually never really considered the differences between what it would be like positioning outside and inside in terms of those, minute, the precision that you need and how that would affect your system. Of course, it would affect the system, because if it doesn't know exactly where you are, how can it position you relative to the data that you're seeing? So that was really good. I'm pleased that you took the time to clarify that. Is this something that can be used offline as well?
Technically, we can use the system offline. Currently, we do not offer that capability yet. We have all the essential components for taking data offline. To provide quality experience at the moment, we require all of our users to continue staying online, but we will have the offline mode later on this year. Now, that's been said, when we say staying online, it doesn't mean that as soon as your internet connection is interrupted for a second, you lose everything. Our system actually intelligently downloads information dynamically for your location, and it stores that information in memory while you're standing in that location. As you move around, typically the information will be more or less static, and as you start approaching the edge of the visible data, our system will preload the next few tens of meters of information. This is the only time when you actually need to be online or when you need to submit reports. Now, in that respect, we have all the components for taking it offline, but at the moment, simply so that we can provide really high quality user experience, we require online presence.
You're talking about field workers before, and I can imagine that working in the field, that would be a big requirement, especially for the likes of a utility company where they're maybe not always in direct contact with the internet, that having that offline capability would just be amazing.
Absolutely. And we have a few clients that actually asked for it. It just as we explore their use cases, the current deployment method doesn't require offline capabilities. One of the challenges with offline is data security, because offline implies that you have to either download the entire database onto a specific device, and in that case, if the device is lost, even if you have all the password protections and encryptions, there is still a possibility of that data residing outside of your organization. So that's one issue to solve. And the second issue is how to keep it up to date. If we talk about typical field services workflow, they typically do not have too much room for synchronizing information or starting their day by downloading new updates to the data. The workflow of caching areas of the information and making that workflow very easy for anybody to follow is the key. We're working through that. We actually had a few design sessions around it, and I'm pretty sure that in the future we will offer it. We just want to make sure that the experience of taking data offline, caching it on your device for a specific area, and then keeping it up to date is as easy as using our core system.
Of course, it's important to have those things. If you're going to release them, then they need to work and they need to be intuitive, and especially with what you're doing, because it sounds like you're taking relatively complex workflows, in terms of being outside, being in the field, finding data, and walking around with your laptop, and all those things that field workers need to do. You're taking complex workflows and you're simplifying them. So why would you then release something that didn't sort of fit in with the rest of what you're trying to do? I completely understand that. So I'm sold. I'm all in. It sounds like a great idea. I can't wait to be walking around with my headset on, seeing geospatial data all over the place and interacting with it. Can you give me some use cases for this? I can see that it'll be amazing visuals, but what are the use cases for this? How is it going to save me time, and what problems are you solving with this?
Well, out of the gate, we need to clarify one thing. Augmented reality, just like any other tool, is not a solution for every single problem out there. Having realistic expectations about what system can and cannot do for you is the key to success. As we deployed system in different environments, we found that firsthand that setting expectations right is the key to a successful project at the end with our clients. Now, what I'm alluding to is that sometimes, based on the science fiction movies that we see all the time, the expectations that the system will do really magical things. And all you need to do is just pull out your phone, point it at the ground, and you will be able to see everything. And then you don't need to have any other tools to do your job. And it's slightly misguided notion because the technology may get there eventually, but without any supporting tools, it wouldn't be able to accomplish what you're asking it to do. Now, going back to use cases, we see the system as a complement to the existing policies and procedures. For example, the biggest use case for us is asset locations. We have a few independent asset locating teams as independent companies or as part of larger organizations. The way they deploy the tool is for specific jobs, typically those jobs that take longer than 30 minutes. They use the tool as the aid that helps them understand where different pipes are, where different assets are, so they have the greater level of confidence once they start doing the actual locate. They still do the same locates or still follow the same locate process as they followed before. They still use the same tools, they still spray paint the ground, but the system helps them understand where the right line is, which line to follow, where they need to find all the different valves to connect the toner to. If the signal disappears, they know where to expect that signal to reappear. So all of that all of these small things speed up the work by about 30 to 50%. Another thing is quality assurance. So quality assurance is the big use case for us. As the person comes back to job site to validate the spray painting, all the locates they've done, and all the markouts they applied to the surface, it makes it very easy to identify whether you missed something or not. Any discrepancy between markouts on the floor, on the ground, and the augmented reality visuals will be highly visible, and that may provoke questions or asking additional questions or doing additional investigation to make sure nothing was missed. So quality assurance, we can help companies save up to 80% of the time on quality assurance. Those are the main use cases for the typical locates. However, our tool is also used for compound maintenance. So if you're talking about, for example, open pit mines or oil and gas situations, when you're talking about airports or university compounds, they have a lot of infrastructure under the surface of the road, and they constantly renovate and they constantly improve the landscape. So knowing where things are in the natural way helps them to do a better job and helps them to do it faster. There are a few other use cases also, but we can go into them later.
That sounds really, really, really interesting. But again, it sounded like it was a whole bunch of visual related use cases of visualization. And I'm definitely not suggesting that you're not solving problems, because you clearly are. But could you envision a time where people could do analysis in this or edit data in this kind of sort of hands-on practical way?
Well, augmented reality is the data delivery tool. It's an interface that connects the user to the data produced by something else. So the best way to understand augmented reality, because as we talk to different clients, we always get different types of questions and different types of ideas. And the key for us is to break it down to the essential components and see if it's technically feasible and if it makes sense to do it the way they're proposing. So the key component for us that and something that we explain to every client we have, is that augmented reality is essentially another screen that delivers data to you. Just like the monitor at home is not designed to analyze things, or it's not designed for any type of analytical processing, it's optimized for delivering data to your eyes, the same way we treat augmented reality. We view it as a potential communication tool, a notification tool, something that brings visuals in front of you, but we don't foresee how that can be applied to the analytical process itself. For example, uh, we work with a couple of companies that develop drones, and they fly drones along the power lines to do the LiDAR scans of the power lines and the surrounding areas. Now, the main objective for the drone flying is to identify areas where vegetation encroaches on power lines, so that you need to trim the trees and bushes and everything else. Now, the analysis about encroachment is done by the analytical tools in the cloud or by analytical tools that they build as the engine. Now, the results of that analysis, though, can be consumed through augmented reality. So in this context, augmented reality would not necessarily process visuals that you see in front of you, but you would fly a drone, the drone will collect information, that information will be processed in the cloud in real time to identify all the areas that require attention. But then when the worker comes to that place, instead of trying to see which street to cut, this is where augmented reality can benefit from the analysis done by somebody else and display, for example, corridor which we need to cut through the foliage right there on site. So going back to your question about analytical component, augmented reality is really the delivery method of information, but analysis will happen somewhere else, and we work closely with a few companies that provide really advanced analytical tools.
That was. I think you did a really good job of explaining that. At least for me personally, I think you made some really good points and had some really good examples of use cases for augmented reality and what it's not for. So I really appreciate that. Is this the future of geospatial?
Well, undoubtedly, undoubtedly. When we look at the landscape of technologies, we see a few elements that will form the foundation of future field services. And we hear all these words all the time, but now we can start seeing real life deployment of those. And specifically, we're talking about artificial intelligence, machine learning, all the drones or unmanned aerial vehicles, and then augmented reality. So once you look at these four components, one of them will be responsible for predictive analytics or for processing complex visuals from something else. Drones will be responsible for information gathering or information delivery, like physical work on site. Machine learning will help with processing findings and scans done by drones. And then augmented reality is the most useful tool for delivering that information in front of the eyes of the actual person doing the work. So we see that augmented reality will be a critical component, not just of the GIS space, but pretty much everything else, manufacturing, military, you name it.
If you're building a website, for example, people talk about we're moving from a desktop world to a mobile first world. I've often heard people argue that we're actually moving towards a mobile only world, but it feels like you're taking this a step further. It feels like augmented reality isn't mobile, it's much, much, much more. And what you're saying now is that this is going to be the future delivery system in terms of geospatial visualization. Is that correct?
Correct. The flat screens still be applicable because flat screens for the computers, for our tablets, they have their own purpose and they're not going away anytime soon. That's been said, there are countless use cases when it comes to recognizing complex 3D shapes, when it comes to seeing information in the contextual format, or when you need to remain hands-free for where augmented reality provides the best experience. Just picture this situation for a second. You are a field services worker, and your job is to find a faulty valve somewhere. And then you need to understand the implication, let's say, of closing that valve and cutting the water flow to certain houses. So when you're standing on the street right now, there are tons of things that you will have to check. You will need to check the work ticket. You will need to check instructions for getting to the valve, then doing some sort of work on the valve. Then you will need to check some geo databases to see what will be the impact and so forth. So there are countless sources that you will have to check, and then you will have to remember how to find them or to check them, because you don't know what you don't know. With augmented reality, you can package it so that the person sees information in a way that helps them to do the job faster. So that example that I gave you about the valve, imagine you're standing now there, instead of your tablet, you have a holographic headset. Now the holographic headset points you to the exact location of the valve, so you can walk there. It highlights the current status of the valve, whether it's open or closed, so that you don't have to do redundant work. Then let's say if you have to close it, you ask the system to display the houses that will be impacted. And the system will highlight the houses on the street that will lose water flow because of your actions. So you can make a judgment on whether it's appropriate or not for the situation. Then you might be a person who has never worked with this type of valve. So the system may display instructions or step-by-step disassembly methods right beside the object while you're working on it. So there are countless ways it can help you and supplement your work and make you much more productive in the field.
Hey, I realize we're running out of time now, and I just have a few more questions before I let you go. And the first one is, where are the humans in all this? It sounds like machines and computers are going to take over and rule the world. And in terms of geospatial, anyway, they're going to remove lots of people out of the equation. If you were really interested in the geospatial industry, what would you do? What kind of skills would you be acquiring right now?
Well, any skill that has analytical component to it will be helpful for years to come. And it doesn't apply just to the geospatial industry. Geospatial industry is no different from any other industry. The way to prepare yourself for the future is to check, can your job be automated? Can it be codified? Do you make any judgment calls, or can it be simply automated by having a machine doing that? There are so many jobs that can be replaced by machines, not because humans are not needed, is because with time, the job is so repetitive that you can design simple processes, and with the appropriate equipment, they can be followed very easily and much more efficiently than a human would do them. So when you choose a job path or career path for you, the key is to check whether there is an analytical or creative component to that. Machines are not optimal for that purpose yet. Maybe eventually, 20, 30 years from now, they will reach the level where they can replace humans everywhere. But at the moment, humans still have to make complex decisions. And humans have to understand different parameters and react to unforeseen circumstances. So if you have any analytical component that, again, I keep going to the word analytical, something that requires you to think and make decisions on a variety of factors that can be unpredictable sometimes, or process information that wasn't structured before you, then it's the great career choice for the future.
Alec, I want to thank you so much for taking the time to talk to me today. I really appreciate it. I think that your work is incredibly exciting, and I look forward to following it in the future and seeing where you end up. Just before you go, can you let us know where can we go to find out more about what you're up to? Where can we follow along?
The best way to find us is by going to our website, www.vgis.io. Again, www.vgis.io. We're also quite active on social media. All the social media links will be in the footer of our website, and we always put news, updates, and so forth on our website. So I would suggest use that as a starting point.
Once again, Alec, thank you so much for your time.
You're very welcome. Thank you for having me.
And that's the end of another episode of the Mapscaping Podcast. Once again, my name is Daniel. I hope you've enjoyed the show today. I look forward to talking to you again next week. And in the meantime, if you have any questions or comments, please feel free to reach out to us on social media. It's Mapscaping on Facebook, Mapscaping on Twitter, and MapView on Instagram. We'd love to hear from you. As always, a full transcript of these podcasts is available at mapscaping.com. Talk Talk soon. Bye.